Good morning, 11th class. In earlier video, we have learned about atomic radius. Now today we'll study about covalent radius, van der Waals radius, metallic radius. Although covalent radius and metallic radius, normally we said what that one is atomic radius. Atomic radius we use for both covalent as well as for metallic radius. Now first of all, covalent radius होता क्या है? Okay, definition wise तो it's a simple definition that you have to learn. Okay, but normally covalent bond, okay, those who are formed by sharing of electron. So simple in this one, you can take example of hydrogen, because hydrogen are formed by what? That one is sharing of electron, that is H2. Now suppose this one is one molecule, sorry, one atom, this one is another, and this one will form H2. Okay, so simple, this one is the nucleus. So how to define covalent radius? It's 1/2 of the distance between nuclei of two covalently bonded atom of the same element in a molecule. Now this one is same element, example किस चीज का? Hydrogen molecule. Both are formed by मतलब hydrogen is formed by sharing of electron. Now तो it's a distance from this to this, just see two covalently bonded atom, okay, and that one is divided by 2. Now this difference, now this one is, just see, 1, this one is total difference, okay, and this one is divided by 2. Okay, in case of homogeneous homoatomic molecule, okay, so this difference, that one is known as covalent radius. Now just see, in case of hydrogen molecule, okay, that is the internuclear distance between hydrogen molecule, this one is 74 picometer. Okay, so when you calculate covalent radius of single hydrogen atom, so this 74 divided by 2, it means that one is again इसका वो कितना आ जाएगा? For hydrogen atom, radius is equal to 30, this one is 37. So just see distance like this, that one is 37 picometer. Okay, total is 74, and covalent radius for hydrogen, तो hydrogen के लिए radius कितना आ जाएगा? That one is 37 picometer. Okay, because simple definition कितनी है? जितना यहाँ का distance है, that one is divided by 2. Okay, but that is for homoatomic molecule. Now in case of heteroatomic molecule, okay, that is covalent radius. कैसे define करोगे? It's a distance between the center of nucleus of the atom and the mean position of shared pair of electron between the bond atom. Okay, actually in case of heteroatomic, you can say heteronucleus molecule, heteroatomic molecules means where atoms are different. मे बी इट्स क्या कहते हैं, इट डिपेंड्स कि आपके डिफरेंट टाइप के क्या आएंगे, जैसे CH4 वगैरह, वेयर बॉन्डिंग इज डिफरेंट, जो दोनों का साइज कैसा है, थोड़ा सा चेंज है. ओके, तो इन दैट केस हाउ टू डिफाइन? तो दैट वन इज सिंपल, इट्स अ डिस्टेंस बिटवीन सेंटर ऑफ द न्यूक्लियस ऑफ एटम, जो भी न्यूक्लियस का उसका सेंटर, एंड दैट द मीन पोजिशन ऑफ द शेयर्ड पेयर ऑफ इलेक्ट्रॉन बिटवीन द बॉन्डेड एटम, की उसने कितनी मीन पोजिशन जो है वो ले रखी है. ओके, दैट वन इज नोन एज कोवलेंट रेडियस फॉर हेटेरोएटॉमिक मॉलिक्यूल. Okay, now next we have that one is metallic radius. So in case of metallic radius, simple, we are talking about metal, and metals generally are formed कैसे बनेंगे? Then in case of metal, covalent bond में तो they are formed by sharing of electron. So in case of metallic radius, okay, that one is taken as 1/2 of the internuclear distance between two neighboring of that one is of a metal in a metallic lattice. Suppose you are taking take example of copper. Okay, so whatever is the copper, now this one is size, okay, another one is also जो भी इसके nearer one है, okay, the distance from this to this and divided by 2. Okay, so this one is simple metallic radius. Okay, next we have van der Waals radius. Okay, now actually van der Waal, okay, generally van der Waal forces are there, that one is weak forces. Okay, that we'll study in detail later on. Okay, but van der Waal forces are weak forces that exist between molecules, जो molecule के बीच में क्या करती हैं? exist करती हैं. and maybe force of attraction is strong, maybe weak. तो van der Waal forces generally कैसी forces होती हैं? weak forces होती हैं. Okay, तो in case of van der Waal radius, okay, how to define van der Waal radius? Simple. Okay, this one is as defined as 1/2 of the internuclear distance between the nuclei of two adjacent atoms of the substance belonging to two neighboring molecules in solid state. थोड़ा अजीब सी है definition, चलो I'll explain with diagram. Just see, ओके 11th क्लास नाउ जस्ट सी दिस वन इज बिकॉज डेफिनेशन में क्या बोला था कि किसका हाफ करना है, दैट इज इंटर न्यूक्लियर डिस्टेंस बिटवीन न्यूक्लियाई ऑफ टू एडजेसेंट एटम. तो just see this one is one molecule. Okay, this one is one molecule. Okay, because as I told you that van der Waals force, they are force ऑफ अट्रैक्शन. तो कितना फोर्स लग रहा है, उनका क्या रेडियस होगा. ओके दैट वन. तो बेसिकली दिस वन इज अबाउट टू एडजेसेंट मॉलिक्यूल्स. अब ये एक मॉलिक्यूल है, दिस वन इज अनदर मॉलिक्यूल. तो जो एक दूसरे से एडजेसेंट है, जैसे एक दूसरे के सामने सामने है, जैसे ये दोनों है, ये दोनों एक दूसरे को फेस नहीं कर रहे हैं. ओके बट दीज आर फेसिंग ईच अदर. तो इनके बीच में कितना फोर्स ऑफ अट्रैक्शन है, उसका डिस्टेंस जितने से ये आपस से क्या हो रखे हैं, अट्रैक्ट हो रखे हैं. एंड दैट वन इज डिवाइडेड बाय 2. okay, that one is known as van der Waal radius. okay, it depends, ये वेरी करता है. okay, कि कितना फोर्स ऑफ अट्रैक्शन है. किसी के बीच में स्ट्रॉन्ग है तो मे बी ये कैसे आ जाएंगे, और नज़दीक आ जाएंगे. थोड़ा वीक है तो और दूर चले जाएंगे. इट डिपेंड्स अपॉन फोर्स ऑफ अट्रैक्शन कि किस टाइप का फोर्स इसमें है. ठीक है, दैट वन इज van der Waal radius. okay, definitions तो obviously language wise you have to learn, but this one is for understanding. okay. Okay, in class now just see another topic, that one is ionic radius. This one is important for reasoning question also. अभी बताएंगे कैसे आ रहे हैं. Okay, now तो ionic radius, you know ions का radius, that one is ionic radius. And normally अगर हम बात करें, okay, if you are talking about complete ionic compound, okay, तो how they are formed? They are formed by transfer of electron. And if we are talking about individual cation and anion, so accordingly their definition is there. So just see, simple, the effective distance from the center of the nucleus of the ion up to which it has an influence in the ionic bond, कि उसका influence कहाँ तक है. okay, that one is basically ionic radius. Now just see, okay, so just see that this one is internuclear distance, this one is ionic bond. okay, take example of NaCl, कोई सभी जो ionic bonds बनाते हैं. okay, तो this one is cation, this one is anion. तो this one जितना भी influence, this one is nucleus, और जहाँ तक इसका influence है, okay, that one is basically known as ionic radius, you can say. okay, तो total इन दोनों का sum कर लें तो internuclear distance कितना आ जाएगा, radius of cation plus radius of anion. तो this one is a complete ionic radius of a ionic compound, this one. Now in case of normal one, if you are talking about single cation or single anion, तो that one is also valid. कि suppose this one is your atom, yeah, this one is your ion. So whatever is the effective nuclear distance from nucleus to outermost electron, effective nuclear distance means you know how cations and anions are formed, by loss of electron and gain of electron. तो उसके बाद जहाँ पे भी आपका इलेक्ट्रॉन है, जहाँ तक उसका इन्फ्लुएंस है आफ्टर लूजिंग और गेनिंग इलेक्ट्रॉन, तो डिस्टेंस फ्रॉम दिस टू आउटरमोस्ट इलेक्ट्रॉन जो इफेक्टिव डिस्टेंस है, दैट वन इज नोन एज, ओके, दैट इज आयनिक रेडियस. तो इट डिपेंड्स कि पूरे कंपाउंड के लिए है या नॉर्मल उसके लिए है. ओके, नाउ इन दिस वी हैव टू जनरलाइजेशन. जस्ट सी हियर ऑल्सो, जो साइज दिखा रखा है कैटायन का, देखो छोटा है, दिस वन इज larger comparatively. So two generalization we have. One is that cations are always smaller than their parent atom, and anions, second one is anions are always greater than their parent atom. Now question arises why. Okay, that one is very important. Okay, 11th class. Now this one simple, cations are smaller than their parent atom. Why? Okay, so this one simple thing is, you can take example of, suppose we are taking example of sodium. Okay, you know that metals have tendency to lose electron and become positively charged ion, means cations. So in case of sodium, if you will see, that one is electronic configuration is 1s2 2s2 2p6 3s1. in outermost shell how many electron is there, 1. okay, so that sodium have tendency to lose one electron and become Na positive. Either you write like this, Na minus electron, it become Na positive, or you can write Na become Na positive, this electron goes that side and become plus. Both are same. So now just see, in this case, okay, previously this one was the configuration, and after that 1s2 2s2 2p6, one electron is removed from outermost shell, and that one is 3s. So one reason why size is smaller, the first reason is after losing electron the number of shell decreases. Just see, नंबर ऑफ शेल ऐसा हो गया, कम हो गया, तो ऑब्वियसली द डिस्टेंस फ्रॉम द न्यूक्लियस, जो इफेक्टिव डिस्टेंस है फ्रॉम द न्यूक्लियस टू आउटर मोस्ट शेल, दैट वन ऑल्सो डिक्रीजेस. Okay, so this one is one reason. Now another reason also we have. Okay, which one? I think you know that one is, this one is second reason, that atomic number, okay, is equal to number of proton is equal to number of electron. Okay, that you know. Okay, so in case of this one, simple, in case of sodium, that in case of sodium atomic number 11, proton also 11 and electron also 11, but after losing electron this one become 10, this one remain 11. Okay, so in case of 11 proton, it means that okay, just see, in case of this one, number of proton, in case of positive ion, when this one is Na positive, this one is normal sodium, this one is normal one. Okay, just see, so in this case both are equal, but in case of Na positive ion, number of electron decreases but proton remains same. It means that one is nuclear charge increases in case of Na positive ion, because electron kam ho gaye, so hence they pull the electron towards itself more effectively. Okay, that's why size is smaller as comparison to parent atom. Hope so this one is clear to you. Similarly, you can write why anions are greater than their parent atom. Okay, reason is because after gaining electron, okay, they acquire noble gas configuration. Okay, that answer you have to write. Okay, after gaining electron they acquire noble gas configuration. Okay, and nuclear charge comparatively less, that's why size increases. Okay, that is the reason. Okay, thank you.